Okay, we're on chapter 7. This is trig integrals. It is not an official lesson in our textbook, but it's a very important topic. So we're going to use a different textbook to cover this idea. All right. So the idea in this lesson is that you have these trig functions in your integral that are to a power, and there's a combo of them. Right? So it's a combination of like sine to the fifth x, cosine squared x, or tangent to the fourth power x, secant square x. So it's a combination of these trig functions to a power. So you want to see how you can create a u substitution that will allow you to solve for these integrals. Right? So the good news is for cosine squared and sine squared, you actually have a formula here that's really helpful. So for sine squared and cosine squared, you have double angle formula, so you can rewrite cosine squared into 1 plus cosine 2x over 2. And then you can take out the 1/2 as your coefficient, and then you can take the antiderivative nicely. Same thing with sine squared x, and now it becomes 1 minus cosine 2x over 2. Again, factor out the 1/2 as your coefficient, and then you can take your antiderivative really nicely. Okay. Now, there's a nice formula here to kind of help you with that. If sine is to an even power, you can actually make it so it's sine squared to that power. So to a power to create that even power. So you can actually do that kind of substitution and use the identity up here to help you. If it's an odd power, then you want to take out one of the sign and use the rest with your identity. So it's actually kind of cool here. So for example, in this problem, you have sine to the fifth x dx. So the trick here is take out one of the signs, so sine x, and then you have sine to the fourth x dx, right? Now, sine to the fourth x is really sine square x squared dx, like so, right? And so you actually don't want to change the sine squared to the identity that we're showing you up there, because it actually will make it a little bit worse. So what you want to do now is use your Pythagorean identity. Your bread and butter is the Pythagorean identity of sine squared x plus cosine squared x equals 1. Right? Hence, sine squared x can be replaced by 1 minus cosine squared. So you have sine x, 1 minus cosine squared x squared dx. And now the u substitution is very nice, because you can see if you substitute the if you sub u as cosine, then your du is out here where the sine x is. So your u substitution should be a little bit clearer now. So now if you say u is equal to cosine x, du is negative sine x dx. I like to move my negative over, so now du equals sine x dx. So now your integral can be rewritten as 1 minus u squared, right? So 1 minus cosine squared, so 1 minus u squared. And then the dx gets replaced by negative du, okay? And what then you need to do is expand this out so it's easier to take the antiderivative, because you don't have a single u on the outside, so you can't just take it directly. So if you were to multiply this out, you get 1 minus 2u squared plus u to the fourth du, and now you can take the antiderivative. So negative u minus 2u cubed over 3 plus u to the fifth over 5 plus c. And so go ahead and put your u back in, because this is u and not x. You want to put your x back in. So you have negative cosine x, right, minus 2 over 3. Then that would be cosine cube of x, right? And then plus cosine fifth of x. So you have cosine fifth power x, and then don't forget your plus c. Okay. All right. So if it's a single sine or cosine function, if it's odd, just take one of them out and then use the rest of them with the identity, and your u substitution should be pretty nicely set up that way. Okay. All right. So now it says if your sine could be odd and even, if they're both even, you can use your identity. So if it's sine squared and cosine squared, you can actually use the double angle identity from the top, and it actually cleans up. It's a lot of work, yes, but it's going to clean up, and you can do the antiderivative. If either of them are odd or both are odd, you want to use the same process as your u sub. So again, you really want to look at this and say, what can I do to create a u and its derivative in this situation. So when you have cosine cube x times sine to the fourth x here, what is a good idea would be to take one of the cosine out, because any even power can be replaced with either the Pythagorean identity or with the double angle identity. So in this case, I'm going to take a single cosine out, and I have cosine square x sine to the fourth x dx. And then using my identity, I know cosine x, cosine square x becomes 1 minus sine square x, and then sine to the fourth x dx. Okay, so now I can see my u sub a little bit better. If my u is sine x, then my du is cosine x dx. Awesome, I see my du, I see my u, so this u sub is actually pretty straightforward. So now this becomes 1 minus u squared times u to the fourth, right? Because that's my sine, so u squared times u to the fourth, and then cosine x dx is my du. Okay, all right, distribute the u's back in, so u to the fourth minus u to the sixth du, and now this is just straight up power rule. So you have u to the fifth over 5 minus u to the 7 over 7 plus c. So put in my u sub back in. I have sine x and sine x, where my u is. So sine to the fifth power over 5 minus sine 7 power over 7 plus c will be my final answer. Okay. All right, so that's a combo of sine and cosine. What if I have a combination of tangent and secant? So here's all this kind of rules for you to use as a guideline. Some people really like these things that are kind of listed out in case scenario 1 and scenario 2 and scenario 3. So if you want, you can actually look through this and see if it makes sense. If it doesn't, it's the same idea as before. You want to take out you want to separate these trig functions so that you can see your u and your u sub, right? So again, I never memorize my identities, but I know that I may need to use something to do with sine, cosecant, something to do with tangent and secant in this particular instance. So off the side here, I remind myself sine square x plus cosine square x equals 1. If I divide everybody by cosine squared, and honestly, this is what I do every time. I don't spend time memorizing this. So I know this is tangent plus 1 equals secant squared. Okay, that means I know I can either manipulate the tangent or the secant. So I see that we have our tangent is odd and secant is odd. So the trick here is to see that if you were to take out a single tangent, right? If you were to take out a single tangent, and you have tangent squared here and secant to the fifth x, you can change this using the identity here. But then that means you're setting up this secant as your u. Well, du is secant tangent, so this alone will not be my du. So this is not a very valid thing to do. So another option, let's see, if I were to set up tangent as my u, right? Or set up tangent as my u, that means then here I need even numbers to transform that into a tangent identity using the Pythagorean identity. So I can only take out an odd one, so it's secant to the fourth x, secant x. So this can be transformed to a tangent, but then that means my u is tangent and my du needs a secant squared. I don't have enough. So then let's see, what's my other option? Knowing that setting up my u as tangent is not a good idea, then maybe setting up my u as my secant would be a better idea. So let's see. If I set up u as my secant, so sometimes knowing what to set up as your u and your du helps you separate the trig functions into better powers to work with, right? So you have your du is secant tangent. Okay, so let's see. That means I need one of each, right? So I need to save one. So I get tangent squared, secant to the fourth, and I have tangent secant dx. All right, so again, take a look at what we have here. We still have tangent cube, and we still have secant to the fifth power, but it just split up. That way I can see this is my du, and then I can transform my tangent into a secant so that this becomes secant, so that I have my u and my du. All right, now this is looking a little bit better. Okay, so tangent squared, it can be replaced by secant squared minus 1. So secant squared x minus 1, using my Pythagorean identity right here. right? And then secant to the 4th x, and then secant tangent x. Doesn't matter, I just switch it so it's a little bit easier for me to see the u and du, right? Okay, so now my new integral becomes secant squared minus 1, secant to the 4th. So my u minus 1 times u to the 4th, and then du. All right, now this becomes the same thing as a previous problem. Now this becomes a very nice power rule. U to the 6th minus u to the 4th, du, and have derivative of u to the 7 over 7 minus u to the 5 over 5, plus c. So you have your secant, that was my u, secant x. So secant to the 7 power over 7 minus secant to the 5th power over 5, plus c will be my final answer. Okay, all right, so again, make sure you practice the problems that we have for this set. It's a really short homework set, but make sure you know why you set up the u's in each of the problem. Okay, all right, that's it.